Let's talk about what happens when you get new information. Like, how does that affect probabilities, right? So suppose you draw a card from a standard 52 card deck, but now maybe you take a quick look and or for whatever reason, you know that this card is red. You're not sure if it's hearts or diamonds, but you know that it's red. And so given that information, what is the probability that your card is a heart? So this is not exactly the same as just asking what's the probability of drawing a heart, right? Because now we have extra information, and so that information essentially changes the sample space, right? So let's think about this. So the idea was that originally you have 52 cards essentially. So this is like your sample space. But now, once we know that that the card is red, so now we know card is red. So now the reduced sample space, which is only the red cards, is gonna be 26 cards, right? So let's write it like this. So the amount of red cards is equal to 26. Now, among these red cards, how many hearts do we have? So red cards are actually either hearts or diamonds, and so half of them are going to be hearts. So among red cards, we have the amount of hearts is equal to 13. And so the new probability that we want, so the probability for a question is just going to be the number of hearts divided by the number of red cards. And so this is going to be, so we have 13 hearts and there are 26 red cards. So this will be half, so 50%, which of course makes sense, but we're just doing this to illustrate what we want to say. So if we know that the deck, so if we know that the card that we got is red, now it's not anymore, let's say, a quarter chance that this is a heart. It has become a 50%, half chance that this is heart. So how do we treat these things in general, right? So in general, when you have a probability and now you learn some information B, you write it in this way. And the way you read this is the probability of A given that B occurred. So now it's not just the probability of A anymore, it's the probability of A knowing that something has happened, right? Knowing, or not necessarily something, but knowing some extra information. So B is like extra information that we have. And how do we compute that? Well, now we know that B happened, so we need to see what's the probability of A and B happening. So let's revisit our example and see how that works out. So if we revisit our example and let A be the card is a heart, this event, B is the event the card is red, so we are interested in computing probability of A given B. And so what is the probability of A? So what is the probability of A? It's the probability that a card is a heart is going to be 13 out of the 52 cards. What is the probability of event B, that is the card is red? Well, 26 of the cards are red out of total of 52. And what is the probability of the intersection? So what is the probability that you get a card that is a heart and is also red? Well, this is actually just 13 again over 52 because it just so happens that every heart is also red. So it's just 13 out of 52. So now we can apply the conditional probability formula to get what we want. So we're interested in probability of A given B. And so this is going to be the probability of A intersection B divided by the probability of B. And so the probability of A intersection B is going to be 13 over 52. And the probability of B is going to be this 26 over 52. And if you write this out, you're just going to get your 13 over 26 equal to half, like we got before.